हाँ देवांशु, हेलो. Can you start the session now, Eleni and Elena?
Am I audible?
Elena
Good
and
morning,
Elena,
everyone.
you are the session chair of this session. So introduce Dr. Rekha Sahu, Silicon Institute of Technology, and we can start the session now. Okay, we have already 21 minutes late, so I think we can start. We have only 10 minutes break today, okay? Not 30 minutes. Okay, Elena, you can introduce our resource person, Dr. Rekha Sahu, and we can start. Yes.
Good morning, everyone. We're now welcoming Dr. Rekha Sahu, an assistant professor at Silicon Institute of Technology, Bhubaneswar. With 18 years of experience in teaching and research, Dr. Sahu is currently engaged as a research scholar specializing in fighting neural networks. Her dynamic research interests also encompass deep learning, machine learning, service theory, and game theory. Brace yourself for an exciting knowledge journey as Dr. Sahu brings a wealth of expertise and curiosity to this workshop. Welcome again.
Rekha ma'am, you can start that unmute yourself and just check whether you are able to share the screen or not. Rekha ma'am, you just unmute yourself. Rekha ma'am. Unmute yourself. You are muted. Elena, am I audible?
Yes, sir.
Yes, sir. Yes, I am.
Okay. So, Rekha ma'am, you just unmute yourself. Unmute. Yes.
Yes.
That's okay. Just check whether screen
Am
is
I audible?
yes, audible. Check whether screen is you can able to share the screen or not.
Okay. Disable, sir?
Disable. Okay.
Yes, host.
Yes. Now you can check. Now you can check. Yes. Elena, just ask the management team, ask everyone to join in WhatsApp group and in email. Session has
Screen is
already.
visible?
Okay, sir.
Yes, Rekha ma'am, we can start.
So good morning, everybody. My topic is Introduction to Machine Learning and Deep Learning and Implementation using the advanced Python. In this section, I will give a talk on the machine learning, give a short introduction to machine learning and deep learning. In the next section, I will go to the implementation part. My agenda is introduction to machine learning, and I'll give a talk on the supervised learning approach, basically on the decision tree and the k nearest neighbor, and also I'll explain you how the performance of these approaches, overall all basic learning approaches. Then I'll give the introduction to artificial neural network, how it converges to deep learning. So let's first go to the introduction to machine learning. Machine learning is the field of study that gives the computer to capable of learning. It is not programmed explicitly. You have some past data, you have some information of previous data. From that exchange, antivirus or not. Machine have to be predict whether a customer will buy a specific product that is antivirus or not. In this case, machine will do it by looking at the previous knowledge, past experience.
Rekha ma'am,
Whether
Rekha ma'am, sorry to disturb you. You can off your video because your voice is breaking. You can off your video.
okay, okay. Yes, sir.
Voice is breaking. You're not getting a bandwidth. You can off your
So
that you will get more bandwidth.
hi, sir. 1 minute. It's not supporting. Okay.
Okay, sharing is over, I think. We can off your video so that you will get more bandwidth because your voice is breaking.
So it's not 1 minute.
Off the video only, nothing else, and share the screen again.
Okay, it's not, computer is not responding 1 minute due to slow.
Yes, that's why your voice is breaking. So you just off your video and you can share and start.
Okay. Yes, sir.
Yes, it's coming. Now just open the PPT. Yes, visible. Continue. Rekha ma'am can continue. Screen
Yes,
is
sir. So
Rekha ma'am, his voice is not coming. Hello. Hello. Rekha ma'am. Rekha ma'am, you are not audible. Leave and join again. Rekha ma'am, you are not audible. Your voice is breaking. Total breaking. Stop sharing and again join. Rekha ma'am. This is the problem in online. Everything is good, but the major problem. Again share the screen. Dr. Rekha, just again share the screen. Sit in a safe place so that you can get the net. Hello? Rekha ma'am, am I audible? Okay, there is some technical issue. Just bear with us. Okay, ma'am is joining very soon. She's changing, going to another room. Okay, so just wait for another 5 minutes. Right? Just wait. Don't leave. Just wait. She's going to start. Ma'am is going to tell about the machine learning, the mathematical. What is the mathematical equations are there behind the machine learning techniques? Okay, actually, everyone is using the machine learning by using the predefined function which is available in Python. But suppose you are going to use the supervised learning, what is the math behind that one? Getting or not? Because if you are going to for the classification techniques, you are going to call SBM and you are going to call one data set or passing one data set and you are getting the result there itself. But uh, how you are going to just fix the equation, how you are going to change the parameters, or how you are going to do the fine tuning, that is going to be taught by the Rekha ma'am in the first half. In the second half, she is going to implement the same thing by using two data sets. Yes, Ankush Radha, are you sharing something? Yes, Ankush. Just bear with me, huh? Just another 5 to 10 minutes. She is going to change and we'll start. All of you have gone through our schedules? All of you have got the schedule or not?
Sir, sharing होनी.
Yes, sir.
Hello, sir.
Yes, Rekha ma'am.
Sharing होनी.
Okay, okay. I'm giving the permission. Actually, I have opted. Okay, now you share. Now you share. Rekha ma'am, now I share.
Yes, sir.
Yes, it's coming.
Yes, sir.
It's better. You are audible clearly. You can start. Make it full screen. Yes, it's coming. Now you can start. Yes, ma'am. Continue.
Yes, sir.
Make it full screen. Make it full screen and continue.
Yes, sir.
Yes. Now you can continue.
So,
Okay, you can start.
sorry for this. So, so the thing you have to consider here the class of tags and the measure of performance and the source of experience. So, for example, one example I already gave you, that is the checkers examples. The checkers example, tags is to here the play the checkers. Performance measure here is the percentage of game won against opponent. You will measure the performance of the machine with how much percentage is won against the opponent. And the training experience here, you will say the practice game on against itself. That is the experiment experience you have to do. So another is the handwriting recognition learning problem. Your task is to the task of the machine is to recognize and classify the handwritten words written in some image form, and the performance measure is the performance measure of the machine learning model is that to how much percentage of work correctly classified by the model machine learning model or algorithm. So, or you can say the approach. Training experience means a database of the handwritten words with given classes is given for the make a model using the machine learning approach. So the purpose of the machine learning is to using some algorithm to make a model, okay, from and to the algorithm learn from the experience, training experience data. Okay. So moreover, we can say how to make computer learn like people learn. Understanding of information processing algorithm for machine learning to a better understanding of human learning abilities and disability. Algorithm has to be invented basing on the understanding of information processing algorithm for machine learning. That is a learning task, theoretical understanding of learning to emerge. Then practical computer program has to be developed in some language for learning and significant commercial application. It uses on the speech recognitions and the loan applications, medical records, and financial transaction. And you can use the machine learning approach here for prediction or do some intelligent works. So machine learning successful in recognizing spoken words, predict recovery rate of the pneumonia patient, detect fraud, use of credit cards, drive automatic cars or vehicles on the public highway, playing game, Google search, etc. Machine learning is successful in this ground. So basically, machine learning is come from the discipline like artificial intelligence, probability statistics, computational complexity theory, control theory, information theory, philosophy, neurobiology. So there are four approaches of the machine learning. How machine learning model can be made, how that can be performed by using the four approaches, one according to which task to be performed. That is supervised learning approach, unsupervised learning approach, semi-supervised learning approach, reinforcement learning approach. Whatever here, you have the environment. Your environment is here, this one, see this figure. And here, from here, you will collect the data experience. That I said three things. The last one is the informations. That is that things, that experiences is come here. Then you will make a model here. Then that model performance is calculated. That is the second one I said about the performance, that model performance is calculated. Then it is checked how much good performance it is giving. And this knowledge is give to the learning elements, and if the performance is less, this is thing go to the learning elements. Again, you get from the environment data experience, you critics find some information here, and to improve the performance standard in the learning elements will change according to the models, and this thing will iteratively done, continuously done until you get a good performance model. Then finally it is go to check here, it is a good performance, then you will go make the model, and final model is created, and this performance is checked, then it is sent to the environment for deployment. So this is the task of the learning things you have done. So basically here is this iteration is the learning thing. You will use the approaches, supervised learning approach, unsupervised learning approach, semi-supervised learning approach, reinforcement, learning. According to your tasks, you will use either of these approaches. So let's go to the supervised learning approach. So here was a pen. Supervised learning approach. To using the supervised learning approach, you must have the data, the historical data or data, experience data, which are in the level form. That means you have the output level. You have some features data, and with his output is given to you. And the model is trained with the guidance of already known outputs data to facilitate the prediction of output level for the future unknown instances. That means when a new you have the data, that is some features data with this output is given to you, and you will make a model basing on that data. Then when a new data will come, new futures value will come, you will predict the output for it. So here you see in the figure, you have this hexagon, triangle, and the square. And this data is given, and corresponding which is the hexagon is given, which is the triangle is given, which is the square it is given. Then taking this data, this level data, these are the features and these are the levels of them. And you can say this is the input, this is the output. Taking this thing together, you will make a model using the supervised learning approach. There is so many supervised learning approach. You may use any one and make a model. Then that will be used on the new data. Suppose two new data set is come here. One is the square, another is the triangle. That model is used on it and find out that this is the square and this is a triangle. That means machine, when you give these two images, the machine will predict you this is a square and this is a triangle. You make the machine using the supervised learning approach. You will make the machine intelligent so that it can able to predict whether it is a square or it is a triangle, all this thing. It is not explicitly programmed. You have to use some algorithm. That algorithm will generate the model, and that model will predict you when a new data set is come, that model will predict you the output. Another is the supervised learning, unsupervised learning approach. Here what's happened, the data given to you to make a model, data is given to you. And that data are on level data. The target data is not given to you. Only features is given to you. The purpose of the unsupervised learning approach is to make the cluster, make the groups. Here you see in this, the system has to be learned by its own through analysis of structural characteristics in the input pattern. You will study the input features. What are the features of the input? Correspondingly, you group it. Okay. No label is given to here. See here, these are some images of the dog and cat. It is not said to you that this image is of dog and this image of the cat. It is not given to you. You will read the characteristic of these images, features of these images, interpret it closely and group it. So you will use the algorithm here to group it. Finally, you will find that there is a model which can able to group the similar type of image here. See here, it is not given that it is dog and it is cat. The algorithm make a model, and this model group this one as this is a one group of data, this is another group of data. When a new data will come, it will say you, the model will process it and say you it is of which group data. It is not explicitly written whether it is a cat or dog, all these things. After grouping, you will give the name that it is a dogs and graph, or you will say this is the cluster 1, this is cluster 2. So, moreover, unsupervised learning deal with the on-level data and group the data according to its similar features. So, another is the reinforcement learning approach. Reinforcement learning approach, the machine will learn from the feedback. This is a feedback-based learning technique in which an agent learns to behave in an environment by performing the action and seeing the result of the action. If getting the positive feedback, then the action is good action. If it is the negative feedback or penalty you are giving, then that is the bad action. The agent learn automatically using the feedback, and there is no level data, no experience. There is experience without any level data. Okay, so here you say this is an agent. This is robot is an agent. He's do action here in the environment. If he is getting the reward here, then he has done the good actions. And you'll always try to do the action for which you will get the reward, not punishment. Always avoid the reward. You try to get the more points. Like in the game, the player try to get the more points. Same way it will be done. So in summary, you can say supervised learning uses a level training set to ease the model to help the desired output. Training data set include inputs and correct outputs, allowing the model to learn over time. Then on supervised learning, training data is not the level data, and the agent here discover the pattern within the data set or semi-supervised learning is the combination of the both supervised and unsupervised learning. Some training data are not level. You can use the grouping concept, use the unsupervised learning, then use the supervised learning to level the data. For some level training data, first you will use the unsupervised learning, then you will use the supervised learning for getting the good performance. So semi-supervised learning is the combination of the supervised learning and unsupervised learning. Reinforcement learning, I already explained you, it try to get the maximum reward, it learn from the environment that is no level data. Okay. Is first do an action. If he is rewarded, if the agent is rewarded, then he learn that it is a good action. Then correspondingly, he will do it in the next step, next actions. So we will focus on, I will focus on the supervised learning approach, and I'll go through some supervised learning approach. So as I said, you supervised learning algorithm learn mapping between the input and the output from the level data set. Input features are some attribute and the characteristics of the data that are used to make prediction, while the output level are the desired output or target. The algorithm try to predict. The algorithm try to learn the relationship between the input and output from the previous data, given level data, so that when a new features is given to you, new feature of an instance is given to you that is on seen data, then it predicts the output. So here, so in summary, you can say that supervised learning requires level training data set to generate a model, level validation dataset to validate the model, and level testing dataset to test the performance of the level. So two tasks can be performed, two type category of the supervised learning approach is there. One is the regression supervised learning approach, another is the classification supervised learning approach. In case of the regression supervised learning approach, the output value, the level value are the continuous value. Like you have given some features and you find out what is the price of a house or what is the temperature of the city. These are the continuous value data. So in case of the regression, the algorithm learns to predict a continuous output value. And in case of the classification regression machine learning approach, the algorithm learns to predict a categorical output variable or class level, such as whether a customer is like to purchase a product or not, whether the disease is able to curable or not. These are the categorical predictions value. So the different supervised learning approaches are there for the regression and classification. Some supervised learning approaches, algorithm can be used for both regression and classification. Some are specifically for the regression, some are specifically for classification. We will go through the two supervised learning approach which are used for both regression and classifications. So before going deep into that approaches, first of all, we go into the data set what is the regression data set and what is the classification data set. See here the data set. Here you have the whether a tennis player play the game or not. You have to predict. So the data is given here. These are the training data, classification training data. Why it is called the classification training data? See here, this is the level data. Our output is the play or not, and the output no or yes, no or yes. These are the categorical values. So you will say that this data set is for the classifications, and it will be classed according to this features value of the instances. We have 10 instances here. We have 10 instances here, and the features of these 10 instances are the weather. What is the weather? And what is the temperature, humidity, wind? In the first day, we find that the weather is sunny and the temperature is hot and humidity is high, wind is weak. Then tennis was not played. So no means tennis was not played. So similarly, in the second day, the 4 features is given and tennis was played is given. And this 10 days information are with it. This is the trading data set. Correspondingly, we can represent it in the matrix form or the mathematical symbols like this. You will represent whether at the xi1 and I is from 1 to 10. Okay, xi1, and the temperature is your xi2, humidity is your xi3, wind is your xi4, and phase is your yi. And correspondingly, you have here cloudy, first, second, third, fourth, fifth, sixth, 7, 8, 9, 10 up to is given. And here sunny means you will write x11. The x11 value is sunny, x21 that is cloudy, x31 that is sunny. Like this, you have the value of this variables. And similarly for the temperature, you have write first row that is 1 and second column that is 2 is hot, and second row and second column that is x22, third row and second column 32. Like this, you will symbolize this hot, mild values, all this second column. Similarly for the humidity, we have xi3 that is for first row x13, second row 23, third row for 33, like this represented. Similarly for the wind, it is represented for the first row x14, for second row x24, so third row 34 of 2 x104. And the level value are symbolized as y1, y2, y3, y4, like this. Or you can take 2 values, y1, y2. For y1, you can take no. For y2, you can take s. Accordingly, you can y1, y2, y2, 2 value we can take here. And for the regression data set, this is the regression data set. Why it is called the regression data set? Here your target value, level value is your salary. Okay, here the features is 7 instances or examples is given to you. This is the training data, and the first and 2 attributes is features, attribute or you can say features is given to you. That is year of experience and the performance. And if the year of experience is for the 7 instances, 7 peoples are there, and his experience is given, his performance is given, what will be his salary is given. What is that salary is also given. You want to predict when a new person is come and a year of experience is given to you, what is his performance in the interview also given to you, what will be his salary you have to predict. So you have to make a model using this data. Here the salary is the continuous values. Since it is the continuous value, you can say this is the data set for the regression supervised learning approach. This is the level and these two are the features. And corresponding mathematical representation of this one is this one, like here you also represent in same way. Your first column is your year of experience, second column your performance. In the first row, first column, that is x11 value is 1. First row, second column is your x12, that is good. Like this, you will represent the data. Next, some mathematical representation of the data set. Why we represent this in this form? So that we can manipulate the values and make a model using the algorithm. It will be easy. So here we can say y is the response of the target value. Sometimes it is called the level value. And the x1, x2, xp. See, here the p means number of features. P is the number of features. You have p features here. These are symbolized as x1, x2, xp. This is called predictor, sometimes called features, attributes, like this. And you have one sample or one example or one pattern means total row. Here you have one row means you can say one example, one pattern, or one sample, you can say, with the features value, with the target value. Here the features value, p is equal to 1, 2, 3, 4. Here the p is 4 and here the p is 2. And y is this one. And xj is your 1 to p denote the genetic variable, represent a predictor, a feature. I already explained about it. And this is nothing a vector which contains p elements. That is the value of the features. And y denote the generic variable. It's not a vector, it's a variable. It is called the target value or the label or the response also it is called. So you can represent a example or a sample as a column form vector containing the features value, that is xi. Xi means ith number of example or sample, that is xi1, xi2 up to xip. Here n stand for the number of training data. Samples is there. How many examples is there? Here you see in this example, you have n is 10, here n is 7. So you can represent xi, this value, xi value are the real values. It belongs to the real value. yi value is also a real value. Otherwise, mathematical manipulation is not possible. That means if it is in the, here you see that here the data are in the linguistic form, sunny, cloudy, sunny, like this. You have to convert it into the numeric form that belongs to some real values, or you can take it as the integer values or categorical value. So for the classification problem, you can represent the data set like this. D is equal to xi, yi. Xi is the features column and y is the target value of it. If you have the n number of training data, you can write here I is 1 to train here. Here the xi belongs to rp, and since it is a classification problem, you have the m classification, m classes. In the previous case, I said you 2 classes. This is 2 class. One is no, another is s. So here you can say m is 2. 2 class means m. Similarly, you have m class. Your y value is belongs to of this class. So in case of the classification problem, you will represent like this, where xi is belongs to rp. R is the real value set, p is the dimensions, and yi belongs to some categorical value. That is, if m number of classes, then you will say it belongs to one of them. So our work is to, you will give the algorithm, the data set, that is D, information, previous informations or historical data, and a new data, new example, one example you have given, and the model will predict your output. And for the regression problem, what happens? Your data set representation is the same way. Our features is represented as the xi and its output is yi. Here only difference is yi values belongs to some real values. Okay, here xi is same as in case of the classification problem, but your target value yi is belongs to some real values. That is the difference between the classification and the regression. And our work is to your data, the work of the supervised learning algorithm is to take this D data, that is the historical or previous data, and a new data, an example is given to it or a sample is given to it. It will predict these are nothing but the features values, and it will predict the output by 0. And these are the tags for the regression and classification. How that will be performed with the decision tree supervised learning approach and k-nearest neighbor supervised learning approach we'll discuss now. First, we'll go to the decision tree. Here, the decision tree is a flowchart like tree structure representations. And here we have the, you can use this for both classification and regression problem. The tree structure, decision tree structure is like that. One is the root node, another are the internal node. These blues are the internal nodes, and these are your leaf nodes. You will construct the tree like this. One is the root node. Root node contains all the data. Root node contains, represent the complete data set. It is the starting point of the decision making process. This contains complete data set. Then you want to split this one using some attribute values. So your blue nodes are symbolized choice regarding an input features. You have some features. What is the value of the feature? Basing on that, we'll split this one. What is this is the total data set. You will choose some features, one features value from all the features, and according to value of that features, you will split this one. And this node again created. Again, subtree. This is another subtree is created. Basing on rest of the sub data set. You have two data. It is split into two data set. Again, this data set is splitted choosing some features and its value. Again, this is splitted like this. And since it is unable to split it for this one, this becomes the leaf node. Again, this is possible to split it. You will split this one. Similarly, here we will do. You have the sub data set. You will split like this according to the features value. We'll go through that details. First of all, you have to know the terminologies used here. Internal nodes, I said you, internal nodes are the blues, are the internal nodes which are considered to split. And then the terminal nodes means the green. These are your terminal nodes. Green nodes are your terminal nodes, that is your leaf nodes. Then splitting, I already explained you. You will choose a features according to value of the features. You will split the tree. Then the subtree, I already said you, subtree means this is a subtree, this is another subtree, again this is a subtree, and this is the subtree. And then the parent node is all blue nodes are the parent node because they are producing the children. Then the child node, these all are the child node because they have the parent. This is a child node, this is a child node, all are these child nodes. Then the impurity, this is a very important concept for the decision tree. Impurity means if you're choosing features, how many when you split the subset in the data into subset data, then how much the subset data have homogeneity in variables value, so in target variables value. Okay, it refers to the degree of randomness or uncertainty in the set of example. The impurity is measured finding the value of the Gini index value, entropy value from the attributes value to the target values. Another is the variances. Variance is the difference between the predicted value and the target value. And it is the error, find out the difference between the actual value and your predicted value. So mean square error and the mean absolute error, these are used for to calculate the variance, the error between the predicted value and the real target values. Generally, mean square error and mean absolute error are used for the regression decision tree, whereas the Gini index entropy are used for classification tags. Another is the information gain. It is used for the classification tags. Information gain is found out from the Gini index and the entropy value, and it measures the impurity reductions by splitting a data set on a particular feature. By choosing a particular features, you will calculate the information gain, which will give how many impurity reduction in impurity is achieved. So you will use this value, you will calculate this value to choose a features and the splitting values to split a decision tree. Finally, pruning. Pruning means your some branches is not necessary to create. Some data is there, it is not needed to create that branch, that subtree, and you have to remove that subtree. That is called the pruning. So moreover, for both the regression and the classification decision tree construction, we follow these 5 steps. First is begin the tree with the root node set S, which contains the complete data set, previous data set. Find the best attribute in the data set using the attribute selection measures. That is, we discuss here the Gini index, entropy, information gain, variance. These things are used to find the best attribute. We'll discuss all these things. And then choosing after choosing the best attribute, divide the whole data set S into subset basing on that base attribute. Generate the decision tree node which contains the best attribute. That according to according to value of these attributes, best attribute is chosen, we split this one like this. And this becomes the node of a decision tree basing on the attributes values. So next we will recursively make new decision tree using the subset of the data set created in the step 3. Then continue this process until a stage is reached where you cannot further classify the nodes and call the final node as a leaf node. You will continue this process for the sub data set starting from step 3, and you will again choose the attribute, again split it, continue this, and until you come to the leaf node where more classification is more splitted is not possible. So for example, for the regression decision tree, I am considering the salary of the baseball players. I find the data set is here. We have given 5 training data set. That is player, 5 player. Their year of experience is given 3, 4.75, 5, 6, 7. And the number of hits in the previous year is the 110 first player, second player 120, third player 130, fourth player 170, 5 is 180. And their corresponding salary is considered as 1 lakh, 1.05, 1.20, 1.30, 1.50 lakhs. It is in the lakhs form. So, so a new person, new player is come, which area of experience is 6.5 and the number of hits in the previous year is 170. How much salary he deserved to be calculated from this 5 training data. So for that, what he will do here, first thing, let's you consider the attribute X1. Attribute X1 means year of experience. Attribute X2 means number of hits in the previous year, and Y stand for the salary here. So here, let's first choose X1. How you choose X1, we'll discuss later. First, we choose X1 and we choose splitting point as the 4.5. Why I choose the splitting point 4.5, we'll discuss later. From this value, the X1 is this one. First, I choose the X1, then I choose the splitting point 4.5. Why I choose the 4.5? All these things we'll discuss. First, we say basing on that, how we are creating the tree. So you have X1 is 6, X1 splitting point is 4.5. So you will represent two attributes is there. You will represent two attributes. X1 is this x-axis. X2 is this X2 axis is here. First splitting point 4.5. So here is 4.5 in the X1. Since X1 is 4.5, so you will take here and draw a line like this. This is a line draw. And here this region representing X1 greater than 4.5, and this region is showing X1 less than equal to 4.5. Next, we'll choose the X2 features. And why we choose next X, how we choose this X2, we will discuss later. And also we choose here the splitting point as 125. Why we choose the 125, we also discuss on that. Same criteria for X1, X2 is the same. Here, when I choose 125 as the splitting point for the X2, and X2 represent the Y-axis, this axis, and the value 125 is here, middle of this much. So here we are considering only this one, these portions. Okay, you can consider also for region 1, and correspondingly you will find the splitting point. Since for now this is not required, I only consider this portions, this region, and in this region we split it into two parts, taking the splitting point value of the X2 as 125. Here the 125, so this region is splitted using this line. So here X2 is less than equal to 125. Here this region X2 is greater than 125. So finally we have three regions. One is R1, another is R2, another is R3. Corresponding decision tree is here. X1 is less than equal to 4.5. Yes, region R1, no region this one. Then X2 is again splitted, and if it is less than equal to 125, then region R2. If it is greater than 125, the region R3. And our data is given here for the new instance, new portion is that year of experience 6.5 and hits, number of hits is 170. So this is 6.5 is your X1 value, and this is 6.5 is greater than 4.5. So it belongs to, according to X2 value, the person belongs to this one. Or if you see the decision tree, the person belongs to the right part of the tree, right sub. Then you will find that the value X2 value is 170, which is greater than 125. So you will find that the X2 value greater than 125 belongs to the region R3. If you see this coordinate space or 2D coordinate space, or if you see this decision tree, you also find here that the new person, that is say X, player X, belongs to R3 region. Now you will consider what is the salary of this X, player X. You find that player X is of region R3. Now you will find from this data set which player are of region X3. Here you see that player 3, X1 value is greater than 4.5 and the X2 value is greater than 125. So this is also region 3. Again, if you choose here 4, 6 is greater than 4.5, 170 is greater than 125. So this is also of region 3. Again, 7 is greater than 4.5 and the 180 is greater than 125. So these 3 are of region 3, but 3 is less than 4.5, 110 is less than 125. It is not belongs to region 3. We only to find the new instead of which region. So again, this second one also you find that this is greater than 4.25, but it 120 is less than 125. So this is not of region 3, it is of region 2, this is of region 1. So these 3 are of region 3. So we will consider the salary of these 3, that is 1.2, 1.3, 1.5 lakh. So you will take the average of this salary and predict that the salary of the X is that much. So here you find that the salary of the 3 is 1.2, salary of the 4 is 1.3, salary of the 5 is 1.5. So add it, divide with 3, you will get 4 by 3 lakhs. So you will predict the salary of the X will be 4.3 lakhs. In this way, you will make the decision tree. This is a very simple examples. Moreover, the rules to create a decision tree is for the classification. This is prediction for the regression. You will follow the same approach for the splitting and doing decision tree for the classification, but last step is little bit different. How to find the salary? Here you will use the different approach. We will go to that. So see here how to make the decision tree. First, suppose you have the 2 attributes, you may have the 3 attributes, the 4 features like this. Correspondingly, we will split this one. And suppose you have 2 features, that is x1, x2. First, you will choose one of them. Suppose I found that x2 is the best variable, so I choose x2. Then I find the splitting value s2. Then we'll make it 2 region a b. If you will take this split value s2. If x2 is greater than s2, this becomes the upper region a. And if x2 is less than equal to s2, it will be lower region, that is b. Again, you will consider second splitting. And for the second splitting, suppose you choose here, obviously only one attribute is left, so you will choose x2. And for the b, first you will 2 region is there. Suppose you first choose for the b, and for b x1, you will choose a splitting point, that is s1, and then b1 is equal to, if x1 is less than equal to s1, s2 is as usual, that is less than equal to s2. You are considering only this one, b1. So x2 here also less than equal to s2, but first thing, x1 is less than equal to s1, x1 is greater than s1, you have to consider, then you will get the region. If x1 is less than equal to s1, this is region b1. If x1 is greater than s1, then it is of b2 region. Next is, so third splitting is for the region A, you will consider the same variable x1, and you can choose, if there is more other variable, you can choose for second splitting, that is different variable. If there is more features is there, you can consider any feature of them, and it may be difference from the third splitting. You may take this is different for the second splitting and third splitting. It not needed that same variable is splitted. So which one is the best for which you will do for that? So x1, so suppose here you are considering x1 and the splitting point s3, and here a region x2 is greater than s2, and for the x1 less than equal to s3, you will consider this regions and that is the left upper part region. And for A2, you will consider that is x1 greater than S3. You will consider this one because here this is the S2 point, and in this S2 point, you will find that this is greater than and this is less than. Moreover, you will find the 4 region R1, R2, R3, R4, and corresponding tree is like that. You will take first x2, basing on this attributes value, you make the subset of this one again using the x1. You will create some condition on that. You will find the region 1, region 2, and this is region 3, region 4. This is your final decision tree, and this procedure is applicable for both the classification decision tree and the regression decision tree. Only is that last evaluation for the region 1, region 2, region 3, region 4 is different. So now the question is which variables to be choose and what should be the splitting values is to be considered. So here the two things is to consider: order of splitting variable among these P feature, which feature you have to consider. Second is what is the splitting values you will consider. Like here, what is the value of S1, S2, S3 we should take. So these two things you have to find out. For the regression, it is different, and for the classification, it is different. First, since we are discussing about the regression decision tree, first we will consider for the regression. So what he will do, he will construct construct a set S. What is set S? Set S constraint Sj. Sj means you have choose some splitting points from the attribute xj. You have p attributes. Suppose you are considering one attribute, that is xj. Xj may be 1, 2, 3, 4 up to p, one of the attribute you are considering, and that values of the xj are sorted in non-decreasing order. Non-decreasing order. Our purpose is to find S here. S contains what? The splitting point values, points values. So you will consider for the Sj attributes. There you have to find the set S. So how you find the set S? After sorting in non-decreasing order, you have to compute the average of two consecutive features value and keep that value in the set S. So set S contains the average value. So here, see this regression problem here. If you will choose J is 1, your first is this one, here P is 2, and you will choose J is 1. So what S will contain here? S is equal to first contain your 1, 2, 3, 4 points. What are the 4 points? That is 3 plus 4.75 divided by 2. That value will be contained in S. Second value is 4.75 plus 5 divided by 2. Average of these two is taken and contained in the set. Then third point, 5 plus 6 divided by 2, average of these two is taken and contained in S. So then is 6 plus 7 divided by, what will be the value? Will be contained in the S. So total 4 values is considered for attribute x1. The set S contains 4 values. So here Sj means, if you consider Sj is that 4 value. S contains that 4 values. Among that 4 values, you have to consider one value which will be the best splitting point for the attribute x1. Here the xj you are right. So suppose xj is the predicate for all attribute. You have to do this one. You will choose Sj. Sj is belong to S. First S1 is choose, and you will create 2 regions. If J for one region for less than equal to Sj, another region is greater than SJ. Like we discussed in the previous example, splitting point, you will consider two region. Here also you will consider two region, and you will find the root square, root sum square, root square sum. Then you will find the root square sum. How you will find this one? You have two region, and all target value is known to you for the regions. That target value for region 1 mean is calculated, and for the region 2 mean is calculated here. Then you will subtract it for corresponding region. See here, for the corresponding regions, xi belongs to region 1, you will subtract mean value for each value, each target value. This y is your target value, and sum it, add it, all this after doing the square. Similarly, for the second region, find y value for each region, that is the level value, and subtract it from its mean value and square it, add it. And after adding all this, you will get root square sum values. And this root square sum value is calculated for all Sj belong to S. Like in the previous example, x1 attributes, you have 4 Sj values that belongs to S. For each 4 value, you will calculate RSS value. Okay, after calculating, you will find the mean among these 4, among all these values, you will calculate the minimum RSS value, and that will be denoted as the xj, where xj denote your attribute, and sj denoted the mean splitting point. So this value you have to find out for all the attributes from 1 to p. You have p numbers of attributes. For all the p attributes, you have to do this, find the value. Again, after calculating all the sj value for xj attributes, for all the p attributes value, you will compare their RSS. That means you have p numbers of RSS value. Among them, which one again the minimum? Here you are considering minimum. Again, you are considering the minimum RSS. That attribute is your best attribute, and with his corresponding splitting values. In this way, we can choose the attribute to split and the splitting points values. So moreover, the algorithm can be summarized like this. Begin the tree with the root node D, which contains the complete data set with p number of attributes. And for the splitting variable attributes, corresponding splitting point are selected using this one for J to P. For each Sj belong to S. S, I already define you what is the meaning of S. Compute the RSS, then you compute the xj Sj. I already explained you what is RSS here and what is your xj Sj. And you have to find this one for each 1 to p. Divide the D into subset basing on the best attribute. You will find the best attribute, calculating RSS for each attribute. That is xj Sj is calculated for each attributes, and the corresponding RSS is calculated.
Rekha ma'am, sorry to distribute. So can you stop it at 11:40? Then again we'll start at 12 o'clock.
Okay, sir.
Okay,
but too much is there. So can I complete this one, decision tree?
Yes, yes. At 11:40, at 11:45 also you can max take to 11:45. Then we'll give 15 minutes break. Then next session will start at 12 o'clock.
Okay, sir.
So 12 to 1:30. Fine. So at 11, before 11:45, we just try to finish this.
Okay. So generate the decision tree, which is split using the best attribute, then recursively perform this one with the subset of the data set, and continue this process, creating the tree until all attributes are finished, or you have the fewer than some minimum number of observation considered in the leaf node. After that, you will consider. Then you consider it. Next, we'll go to the classification tree. You same procedure you will follow to find considering the tree, but how to split here in case of the classification tree is different, because in the previous case you are able to find the value of RSS because these are the continuous value, but here the Y value is your categorical value. So here the choosing of the variables and the splitting point is little bit different. So so here after considering the attributes values, after consider the best attribute and splitting point, making the tree, you will find the region R1, R2, R3 like this according to your splitting. So many region you will find. In that region, you have find the class values, that is 1, 2, 3, 4, K of the region of among these K classes. Suppose this is a classification data set, you have K classes. And some region, suppose RM is a region, it contains NM number of observation, and observation means this contains, like in the previous case, in the example I said you that region 3 contains 3, 5, 6, 7 instances. Here also you find that is 3 observation. Here also you will find region RM with the NM observations. After getting that region and the number of observation, it may be 5 or some observation, you will find the class probability values for here. That is, you will take 1 if class value is C and divided by total number of observation. Like this, you calculate the probabilities values of the class below the instance belong to the class. Then you will take the maximum of probability value belongs to a class, maximum probability of the class. Then it will be predicted at the class of an instance. So how it is calculated? So how we use this one? How we can find here the variables and the splitting point in case of the classification tags. I already explained you for the regression tags. Let's go to the classification tags. We'll use here the Gini index, entropy value. There is so many other evaluation procedure is there. We can follow that procedures and find the value for the splitting variable and splitting points. Entropy value is the formula for the entropy value is equal to E is equal to minus summation of 1 to n probability of an example belongs to a class log of 2 probability of belongs to a class. And the information gain for the entropy, you have to calculate the information gain, that is the entropy of the parent minus entropy of the children. Here is an example. Suppose you have the 15 number of data set and its target value is exam result. Here is the target value. This one, second column. First column is the serial number. Second column is the target value. Third column, third, fourth, fifth. These 3 columns are the attributes value. This other courses is done or not. The value is Y or S or no. Y stand for S, N stand for no. And the student background, it is of the student is of which stream, mathematics or computer science, any other. 3 values considered here. Another is the working status, whether the student is a working and studying or only working. Is that not working means the student is only studying, and working means is working also is studying. So these 2 values are considered as the working status. So entropy for the parent you have to calculate, because you have to for the entropy and information gain, you have to calculate the entropy for the parent. Here you see entropy for the parent is calculated using the target value. Here target value is 2 type of target value, whether it's passed the exam or is failed the exam. So here you have 2 value, pass, fail. So number of pass is 8, number of fail is 7. And so entropy of the parent is equal to using this formula, using this entropy formula, probability of pass you have to find, probability of fail you have to find. So here, what happened? Probability of pass is 8 and total number data is 15. So probability of pass is 8 by 15 and you have to find the log to 8 by 15. Again, so probability of fail is 7. So 7 by 15, log to 7 by 15. If you manipulate this, you will get 0.9968. Next, we'll consider 3 attributes. Among them, one is other online force. Its value is y, yes or no, and corresponding target value is given to you. Basing this 2 value, we'll calculate the entropy value. First, we'll consider for y value. Yes, he or she has done the other online force is 8, and no is 7. Not done is it? Among S, 8. Pass is 5. When you analyze this target value, you find out that among this 8, you find that the pass is 5, fail is 3. So entropy value for y is equal to, again the same formula is used, that is minus 5 by 8. Minus 5 by 8 log to 5 by 8 minus 3 by 8 log to 3 by 8. Fail is 3. So the value is 0.954. Similarly, for the no, you have to calculate the entropy value is 0.953. So total entropy value for other online force attribute is equal to y is 8 by 15. Its corresponding entropy value is 0.9544 plus this is your 7 by 15. Its corresponding entropy value is 0.9852. And when you calculate, this becomes the 0.9688. So information gain is equal to entropy of the parent minus entropy of the online force, other online force. This becomes the 0.028. Similarly, you will calculate it with the student background. That is here is the 3 attributes for the student, 3 values for the student background. One is math, another is computer science, another is other values. And correspondingly, number of math is 7, number of computer science is 4, number of other is 4. And corresponding entropy value is calculated taking how many pass is there, how many fail is there among the math background, among the computer science background, among the other background, and corresponding entropy value is calculated as the 0.9852, 0.000, and finally the entropy value of the student background is equal to 7 by 15 into this value. Correspondingly, you will get that this is by mistake written here 0.296. This is 0.9852. Here is the 0.9852. So finally, you will get that 0.4592. And the information gain because of the student background, it is 0.537. Similarly, you will calculate for the working status. The working status, you will get that entropy value 0.1852. Here, 2 value is considered. One is not working, another working. Correspondingly, 9 and 6, the partition 6 are working and not working. So next, finally, you find the other information gain for the working status is 0.1858, background is 0.5370, online course is 0.028. Among these 3, you find that this is the maximum value. You can gain more information by taking these attributes for the splitting. So you take this attribute. In this way, you will choose the attributes, and the splitting point, that is as I discussed, is considered the variety here, that is math, computer science, other. And taking this, you will consider this data, the student background data, because we use student background to split here. So corresponding pass fail is calculated, and this is summarized here. Math is 4 pass, 3 fail. If they are taking computer science, they positively pass in the exam. If they other course, they positively fail in the exam. So only here, since this is belongs to one class and this is belongs to one class, you have 2 class, pass and fail. This is belong to one class, so you will stop here. This becomes the leaf node. and you only have this one to consider. So next we'll consider this here. So you have the subset of data that is only of the math background data. So only math background data. So you will again to find the entropy, again you have to split. Either you are left with these two attributes. Which one will be selected? Again, you have on this data set, again you will calculate the information gain after calculating the entropy, and you find here that the student background already calculated previously. Only from the data these two is calculated. You find that the information gain, if you are taking the working status, the information gain is 0.5216. If you are taking the online courses, then it becomes the 0.0319. Since maximum is 0.5216, you will choose the working status. Then finally, you find that splitting after that, working, not working, you get that 3 pass, 1 fail, and this is 3 pass, 0 fail. Since it is purely of one class, so you don't need to consider this one. This becomes the leaf node, and you only have this one to consider. Now you go to the data set, which is only that student background is math and working status is W. So you will get this sub data set. Among this data set, you find that math working, if it is not doing online class, is fail. If he is doing the online class, again fail. So in the, again, if not doing the online course, pass, not doing a fail. So these values, using this value, you are not going to find any class values, pure class value. So in this case, you have to stop the tree. And what happened in this case, you have to calculate the probability value. Here total number of example is 4, out of which 1 is pass, 3 is 4. So the probability of pass is 1/4 and probability of fail is 3/4. Any new instance belongs to this region. This becomes one region, belongs to this regions. We'll say that probability of pass is 1/4 and probability of fail is 3/4. Since it is belongs maximum is 3/4, then the machine will predict that the student will fail in the exam. Then another is the you can use the Gini index approach. Here you have to find the minimum of Gini value to split the value. This is another approach to choose the variable for splitting, and you have to calculate here the probability of randomly select an example here. So here is the data, and corresponding Gini value is created as y is pass, and here parent Gini is not, Gini of parent is not required to consider. First we consider here the other online course. You have 8 y here, pass is 5, fail is 3. So correspondingly, you will find the probability square is subtracted, and for the n you also calculate the Gini, and finally you find the Gini other online course value is 0.479. Similarly, you will calculate for the student background, you will find that the 0.2286. Similarly, you will calculate for the working status Gini value, that is 0.378. And finally, you find that the student background Gini value is less, so you will choose the student background to split one. After splitting, you get this, again you will get this information subdata. Then you will again find the Gini value for the working status and online course, and then find the minimum value. This one is the working status is minimum value. Again, use the working status for the splitting. Finally, in this case, you are not possible to split using the online course, so you have to find the probability of pass. Only the different manipulation is done between the entropy value and the Gini value. So finally, the algorithm is to begin with the all the data set, find the Gini index, entropy value, divide the data into subset based on the best attribute, generate the decision tree based on the containing the best subset of the best attributes, splitting the subset. Then recursively perform this work and stop when the leaf node belongs to a single class, or the manipulation from the predicted probability, and that is manipulated from the predicted class probability distribution.
I think Rekha ma'am, we should stop here.
Yes, in the next we can discuss the KNN.
I think in the next session, within 15 minutes, you just try to finish KNN, then the hands on. Okay, so at 12 o'clock again we'll join 15 minutes.
Okay, sir.
And thank you.
Thank you.